everybody. In this video, we're going to talk about how to compare fractions with common numerators and common denominators. So this is one method that you can teach your students to help them compare fractions. And it only works if they have the same numerators or the same denominators. So in later videos, we'll talk about what to do if they don't have the same numerators or denominators. But this is a good start for helping your students understand how to compare fractions. So if you have two fractions that have common denominators, that means that the wholes are cut up into the same number of pieces, which means that the size of the pieces are the same. So in this case, because we have denominators of 3, our wholes, which I'm choosing to represent with area models that are circles, but you could use other models. Those wholes are split up into 3 equal pieces. And in 2/3, we have 2 of those pieces shaded, and in 1/3, we have 1 of those pieces shaded. And so that tells us that 2/3 is the bigger fraction because you have 2 of the pieces compared to just having 1 of the pieces. And you can also show the same concept on a number line model. Like, for example, if we were trying to compare 3/5 and 4/5, the denominator of 5 tells us that we're splitting up the distance between 0 and 1 into 5 equal sized pieces. And the fraction 3/5 is 3 of those pieces away from 0, while the fraction 4/5 is 4 of those pieces away from 0. And so because the purple dot is further to the right than the red dot is, that tells us that 4/5 is greater than 3/5. And so this is the basic idea of how you compare fractions when you have common denominators. You just look at the numerators, which tells you how many of the pieces are shaded, or on a number line model, how many pieces you are away from 0, and you just choose the bigger number. Now, if you have common numerators, it works a little bit differently. So if I was comparing the fraction 1/2 to 1/4, a lot of students will say that 1/4 is bigger because 4 is bigger. But this is actually the opposite of the correct answer, because if you were to take a graham cracker and cut it in half and give someone half of it, versus if you were to cut it up into fourths and give someone a fourth of it, getting a half is going to give you a lot more graham cracker. And this is actually something my mom did with me when I was growing up, that really helped me understand the reason why a fraction with a smaller denominator is actually going to be a bigger amount, because you're splitting up the whole into less pieces. And so if you have the same numerator, then you just look at the denominator, and whatever bottom number is smaller, that's going to be the bigger fraction, because your whole is getting cut up into less pieces, versus with 1/4, you're cutting it up into a bunch of pieces. And you can also show this on a number line. So you could say 1/2 would be the distance between 0 and 1 cut up into 2 pieces, where you go 1 of those pieces, versus 1/4 would be splitting it up into 4 equal sized pieces like this, where you only go 1 of those pieces. And so you can see the 1/2 mark is further to the right than the 1/4 mark. And so that also shows that 1/2 is greater than 1/4. And I would recommend, when you introduce this to your students, that you start off with unit fractions like this, where you just have a 1 in the numerator. But once they have a good understanding of the relationship between the denominator and the size of the pieces that you cut the whole into, then you can do things like this, where you have a numerator that's different than 1 matches. So like in this case, we have matching numerators of 3. And that concept we talked about on the last slide is still relevant, because having a denominator of 5 means that the 3 pieces you have are bigger pieces, because you have a whole that's split up into 5 pieces, versus in the yellow number, we have 3 pieces that are smaller because the whole was split up into 7 pieces instead of 5. And so this shows us that 3/5 is greater than 3/7, because the pieces are bigger. And you can also illustrate this with a equal shares problem. So, for example, if you were given 2 pizzas, would you rather share those 2 pizzas with 4 people or with 5 people? And obviously, your students are going to know if you want to have more pizza, just share it with less people. And so, if you were sharing 2 pizzas with 4 people, that would be the fraction 2 fourths. If you were sharing 2 pizzas with 5 people, each person would get 2 fifths. And so, since you would get more pizza if you share with less people, that tells us that 2 fourths is bigger than 2 fifths. So, that's kind of a word problem way that you can introduce this same concept. And a related strategy is to look at what's missing. So in this case, we have 7/8 and 9/10, and none of these numerators or denominators match. But if you look at what's missing or what it would take to get to a whole, you can compare those. Because for 7/8, the thing that's missing is 1/8, and for 9/10, the thing that's missing is 1/10. Because if you were to add 1/10 to 9/10, that would make a whole. And so in this case, because this is a bigger fraction that's missing, and this is a smaller fraction that's missing, 9/10 is going to be the bigger number because it's missing just a little bit to make a whole, versus the 7/8 is missing a little bit more to make a whole. And you can also do this even if it's not just one unit off. Like in this case, we have 5/7, which would take 2/7 to make a whole, and 3/5 would require 2 fifths to make a whole. And if we look at which amount is bigger, well, 2 fifths is a larger amount, but this is the amount that's missing. So if you have a fraction that's missing 2 fifths, it's missing more than the fraction that's missing 2/7. And so that tells us that the green fraction is bigger. So this is kind of a more complicated application of the idea of common numerators, but it is a method that some of your students may come up with on their own. So those are the strategies for comparing fractions with common numerators or denominators. If you have any questions, let me know, and I hope you have a great day.